I forgot to pull the chat up. Let's pull the chat up on the other screen. All right. While I'm waiting a minute or two for people to show up, hello, I'll get a drink and then we'll start. We will begin. We will commence. Our big change is going to be made. Yeah, we're going to be working. There's a very big change, right? And we're working on a large component of that change. I'd say there are maybe 4 or possibly 5 components. We're going to do one, and then depending on how successful it goes, we might start the next one, you know. But yeah, I'll explain exactly in a minute or two. How much of a chance is there that subs get access to online playground? Probably not much. So the thing is, an online playground thing isn't that interesting because that sort of thing is good for small programs that are not that interesting. And that's not really, you know, we're not that focused on small programs that are not that interesting, you know? We're about how do you make it tractable to make big, complicated programs? And so, you know, we just need to get the compiler to where we can ship it to people. That's it. And I don't want to mess around a lot with diversions on that track just because that could cause it, like spending energy on other things could cause us to actually be later on the main thing. And I don't want to do that. All right, I'll get a drink and we'll start. Earlier, I was working on the using system and I said something about a feature not being doable. What happened with that? I don't remember what feature you mean. Maybe you could give me more information so that I could remember. What are the chances that you or a watcher might have access? Well, we're not even in like closed alpha yet, so it's just too early to say stuff like that. You know, I wouldn't encourage you to wait on any project. If you want to do a project, just start it. And then if you want to translate it over later, it's not that hard. You know, it's not that hard to move in from C++, you know. So the hard part is making a game that's interesting. So just get started on that, and then you'll have a head start if and when you might want to switch languages. When is it available? We don't have a specific schedule. Wow. Hey everybody, I just left my stovetop on for like 2 hours since breakfast. It's just been going. Good thing I didn't put my hand on it. You would have had an entertaining sound collage in the background. Well, let's get started. So, let me start the game. Oh no, let's go to Bard's. Well, okay. We're going to keep that in the cubby for a second. Okay, this one. Lily test. So in the longer term, which hopefully won't be that long now because we've done plenty of other supporting things, my goal is to rewrite the way that movement works in this game. You know, it's a turn-based game, and the movements are all discrete in principle. So you go from square to square, but there's time-based stuff too. And so it's kind of like a real-time plus turn-based system. And this causes weird issues. And it turns out that the way that we are doing movement has several problems. One such one thing that you can make happen, for example, is like, let's say I push this gem onto this guy's head. Never mind that it went through his head a little bit. It's just because he's taller than one square. We'll probably, if something ends up on a person, they'll probably go into a hunched animation that makes them lower than holding it or something. So, you know, I push this thing, it falls for, oops, there it fell to the ground because the guy wasn't in the right place. It falls for a couple of squares and lands. The way that a movement side to side happens right now, and the way that a movement like falling happens right now, is the same thing. Oh, let me slow down time. So there's this system called the Visual Interpolation system, and these debug boxes are just showing what the moves are. And so there's this move type called linear move. There's also a teleport type. There's a couple of teleport types, actually. But something moves from square to square, either horizontally or vertically, by just, you know, putting that value, linear move, on this data structure and putting the start point and end point and all that. And that's fine. The place where it's not fine is when you start having more complex situations. Well, for example, if a person is just walking around with this thing on his head, there's actually two linear moves. The boxes are overlapping, so it's hard to read. But you see how, you know, the guy has a move and that diamond has a move. And what's happening is the diamond's move essentially says, it's a special kind that says, I'm synced with the guy under me. And that's how carrying occurs, which works fine in simple situations like this one. It doesn't work fine in situations like this. So here we've got these lily pads. Now we've got a bunch of overlapping boxes. They're just moving all the time. And they work by having one of these linear move structures. Now there's only one of these globally on an entity about what that entity is doing right now. And let me turn this off so you can maybe see better. The problem is the guy is being carried by the lily pad, so he is essentially, every time the lily pad moves, he is getting a move. His movement slot gets assigned the value, hey, I'm moving by being synced with this lily pad that I'm on. But if he tries to move himself, what'll happen is, you know, his move will get canceled by the lily pad's move, depending on timing. So if I move at the right time, like after the lily pad moves and before they move again, then I can sort of complete my move. But, you know, it looks kind of messed up. And really bad things, if I try to move a lot, you'll see it's kind of spammy. And this makes even simple things bad. So like if a lily pad was just moving by some land and I tried to walk off it onto the land, let's make that happen. Right? So, well, sometimes it'll succeed and sometimes it'll fail. Like, let's see. Well, it's not really failing right now. Oh, right. To fail, it would be... So let's say we have a situation like this, which is not that uncommon. It didn't... Well, there are particular levels where for... Okay, that didn't work. Yeah. There are particular levels where for whatever reason, this is actually very hard to do. Oh, it's skipping stone. Okay. Okay. Here, let's set up a more crazy situation that works less well. So the thing is, his movement is fast enough relative to the lily pads that an orthogonal movement can mostly get you onto the square, I think. But if we do something like this, let's say let's get one of these and one of these. This is a little bit more contrived, but this situation actually happens. Okay, so actually, let's just do this. Let's simplify. So this stone will skip across the water when he pushes it. Never mind that she's not exactly standing on it. She really is. It's just a thinner mesh. So she's going to ride on this stone when he pushes it, right? Now you can see, first of all, that the sync system is not exactly caught up for whatever reason. Like, she's lagging behind at first. That's a little weird. I would debug that, but it's not totally... What did I do? I think there's an extra lily pad. I accidentally pasted one. Let me see. No, there's only 9. Oh, it's because this thing, right, the stone messes with the flow of the lily pads. Okay. So if I try to switch characters and get off the rock onto the land, she's 1 unit up, so we want this to be 1 unit up. Like, I couldn't do it there. Let me... Okay, it worked the second time I slammed up, right? But not the first time. And the reason is just because the rock is moving fast enough that, like, she can't get off it reliably because she starts to walk. Let's slow down time. She starts to walk, and then her movement gets canceled. So we push, and I'm going to go. Okay, that time was fine. Go. Oh, see, she tried to go, and it got canceled. Let's do it again. It's hard because you can't really see when I press the key, but I'm going to press now. She didn't do any. Okay, she started to try to walk and couldn't go anywhere, right? Let's try again. I'm pressing it. Now. Didn't do it. Now. It did do it. So it's very inconsistent. And also those animation problems and stuff, right? So this whole model that there's just one movement slot on an entity and we overwrite it in cases of things like being carried or being pushed or falling, that was a totally fine model to get the game up and running. You know, we built 250 levels with that, but it falls apart when you start doing things that are very sophisticated. And so we need to fix it. It needs to feel good and it needs to feel robust. So part of shipping a game is you go from the draft phase of how things worked into the final phase. So what I was going to do today was start to reduce the usage of that visual interpolation system that's what the struct is called on the entity that holds the movement. It's called visual interpolation. I want to reduce the use of that system and turn it into more like what the component systems are. And again, this is going to be making it look more like an action game's movement would be. And so today I thought, well, in a case like falling, right, instead of having falling queue up some visual interpolations for this entity, like there, it's got 2 interpolations and it hits the ground. Let's just have falling be orthogonal to it, right? Like if something is falling, it's good because we already have a separate Boolean on entities about whether they're falling. And so if something is falling, instead of assigning a visual interpolation, we can just make it say, well, if I'm falling, move downward, and if I have changed my proximity grid square, then put me in the new grid. People who have been watching the past couple streams will have seen that that's a thing that we did. So falling is one case in which these synchronized visual interpolations happen, right? Pushing and pulling are another one. So I can push, and that syncs that. So if we're successful with falling, maybe we attack pushing next. The thing about pushing is it's relatively complicated. Like I can push 4 things at once in a line, right? And maybe the one at the end is blocked. So you kind of want a pretty intelligent handler for pushing. Oh, I'm at the edge of the map. This map needs to be bigger. It's okay, it's just a draft map. Why did that not make a water splash? Did we break water splashes? Oh, maybe it's just, I bet it's just those object types. Let me find a draft level that has a rock that's easily pushable and won't like skip. Okay, let's do this one. Okay, we didn't break water splashes. It's just only certain entities trigger those right now, which is fine because, I mean, we should have a generic one for unhandled entities, but in a real game, you want to have different splash effects because it feels better for different things. So, you know. All right. Alrighty. So I want to basically change falling today. And if that's all we do, then that's a good major step forward. It's going to involve some grunt work because the current visual interpolation system, when it comes to falling, has some properties that we don't exactly like. Like it actually, if things fall and let me see if we can see this by slowing down time. Things kind of fall and then pause slightly and fall and then pause slightly because it's turn-based falling. I don't know if we'll be able to see it in 2 squares very easily, but let's see. So I'm going to push this to this edge, and then we're gonna drop it. So it goes, fall, fall. See those pauses? The animator doesn't like that. Well, there's only one pause because it's 2 squares. The animator doesn't like that, and I have to agree that it's probably not ever going to look good. The original idea was that maybe people need to be very cognizant of what square things are in, but in reality, that's one of those things that I don't think is going to matter. And so we should have it look smooth. So let me put this higher up, and you'll see it pause every time, right? So shoop, shoop. It's a small pause, but it matters in terms of the timing of things. And now the one reason why that matters is because our gameplay recording system for levels that have falling is based on timed playback. And so when we get rid of those gaps, those pauses, it's going to change those levels. And in order to make sure everything is working, we need to be able to go back and play those levels successfully. So I'm going to have to re-record some tests. We might adjust falling speed. We probably want to make a way to adjust falling speed on a per level basis, by the way. Like maybe there's a moon level or something. Let me write that down. That's gold, dude. Level, colon, moon, falling. Just where people fall real slow, because we have sort of per level parameters like how quickly do stones skip, how fast do lily pads move, how fast do the little rover robots move. But we don't have a falling scale in here, and we probably should. And so that will jack around the timing a little bit. And so, it's going to be more than just a programming task to do this one step. There's this data step. There's a gameplay testing step, right? But once we do all of those, we're in good shape because we will have separated out an important part of the system, right? Yeah. Looks like water is further down. Water can't really be further down. It's programmed to be at z equals 0. Although you're right, it's not really affecting. This is very weird. Like, do we have a bug if the ocean? No. Something's going on. You're right. It does look like it's further. Oh, okay. I know what it is. I know what it is. The ocean map markup. Okay. It thinks there's solid ground here everywhere. So this is z equals 0 where the ocean is. But these are all marked as solid ground. And the reason we do that is so that you don't have to instantiate a ton of blocker entities all over the place for maps. Like island maps where you're just going to drop in a bunch of island meshes and stuff. So, I could clear this out square by square, or I can run ocean init, which will clear these except for there. The thing is, when you do have blocker entities like here, these are redundant and unnecessary, but whatever. So let's save that. So now if I push it, there we go. There we go. So we do have a generic splash. All right, much better. I don't remember why we saw the need to put this up by 1 in z, but it probably happened at some point while we were editing lots of things. Oh, because we used to have a pit on the earlier version of one of these levels, and then we copied it. These brown blocks will be switched to other 3D assets later on. Yes, they will. Yes, they will. I'm not going to do super off-topic programming language questions right now. I'm staying on topic of what we're doing. Okay. Well, let's just get started. Let's go to Bardstone test, which is just, the name doesn't really mean anything. This is just a generic level where we test a lot of things. I'm going to set up something here like we just had, where we're just going to have a block and it's going to be up high, just like we had on the other level. So maybe we should have used that, but we're just going to like push it off a cliff. That's all. One block off a cliff. Very simple. And we want that to work. And it will work initially, and then probably we're going to break it. Right? And then, all right, let's make a new camera. Boom. And I go, bam. All right. Let's see that with the pauses. Boop, 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 boop. They're not very long pauses right now. Boop, 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 boop. Boop, 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 boop. All right. So, well, we want that to work. So let's go to falling. Well, let's break it. Let's break it. So we have this time per fall variable, right? 0.1 seconds. And we decide when it's time to do a new move. You know what? We're going to get rid of that because it's not going to be moved based. It's going to be continual falling. And we will stop falling when we are supported. But this routine actually checks for support, I believe. Now here we say if we are moving, we're gonna change this. We're like if we're moving and this is all to do with the old system. Here's what we're gonna do. We're gonna say if e dot falling. Let's make sure falling is on. I think it's on the base, right? Yeah, so we have this Boolean that says whether we're falling or not. So if we're falling, then if we're supported, stop falling and return. All right, that's all fine. We're going to delete this, which is obviously more complicated. We're going to delete this falling time of last move, and we're going to deprecate it. We're just going to rename it right now. That's currently a version 3. We're going to say it's valid from version 3 to 9. We'll keep this one because we use this for gameplay purposes. But this one I think is only used for issuing discrete moves, and they're no longer going to be discrete moves. All right, so we get rid of this. Wait, okay. Yeah. We get rid of this gameplay effects testing. That has been a bug. Let me. So this thing, the way that we test for gameplay effects, like, you know, there are some triggers in the world, like, hey, if this square is occupied, do something, or if this path is blocked, do something, right? And those would happen when, for example, a thing completes its visual interpolation, and falling was one kind of visual interpolation. So when something completes a fall move, we would say like, hey, is this going to get hit by something, or is it now in a beam, or whatever? The problem is if other interpolations happened and like canceled them, then we would never do that check. And sometimes weird stuff happened that caused us to issue this warning like, hey, it's time to fall, but we're not ready to move again, and that seems really bad for whatever reason. That's not going to be a problem anymore in the new system. It's just going to be gone. Going to be gone. If we're in an endpoint beam or something that teleports us, we're still going to use the visual interpolation because it's not really a ballistic fall anymore. We'll change this later, but this is going to live for a long time because by the time we change this, we'll probably just be changing the name of the struct, because if you decide to teleport, you're canceling whatever other motion you had, right? So that's probably not going to change. No check-in doesn't work, I guess. Okay. I guess since we're calling update falling entity, we probably know that it's falling, right? Yeah, or at least, so it's a slightly different thing, this Boolean and this array of all the falling entities, but they're supposed to be synced with each other. So we actually can do that. And this seems redundant, although maybe we needed that for some reason. I don't think so. we don't need this. And this maybe kill things and whatever. This stuff here is stuff that should happen when we are falling into the new square. And we're going to have to move that. Because once we make it more like ballistic, or not really ballistic, but continuous falling, then we need to trigger this code at a special time. And we don't have that time yet. But we will in a minute. All right. Who's using that? Okay. Well, now this thing should no longer fall. Oh, we're not even starting in the right level, but yeah. So I push this gem. The gem is not falling. I'm not falling. But I'm also not supported, so like you can't push if you're not supported. Normally that would be alleviated by you falling, and then you would be supported eventually, or you would drown. But I can't do anything now. The game is just kind of locked. So that's all fine. That's expected. So one question that I have is, I'm doing this code in update falling entities, and should I keep it here, or should I try to combine it with the visual interpolation system? And my answer, or with the time when the visual interpolations happen, my answer is going to be, I'm going to keep it here for now, and maybe we'll combine it later. The reason you would combine it is that when somebody goes into a neighboring grid square, you want to like do stuff. Like check if, like, there's this rule that every time something moves a square, for example, dragons will breathe by one. And, maybe you want to trigger that, for example. Yesterday in mount, we have an example of this, where we say, if something needs a physical move, well, I guess we should call has moved here. Let's look at what we should call. Well, that's just for the mount system, though. So this isn't... so what we really need to do is just set this thing that says manager needs reevaluate is true. But I don't want to copy and paste this. So I'm going to say check for physical move, right? And that's just going to be you know what? I'm going to go maybe physically move, because we're not even checking for it. We're like actually doing it. So we remove it from grid. Okay, we'll comment that out for now. Maybe physically move. So okay, this is fine. Now we want to do that in falling. And let's have maybe physical, well, let's not even have it return true. We can have it return true if like a thing probably moved. Actually, so we have this situation. So things are a little bit complicated. So here we say, like, are we supported? Okay, stop falling. But here we also say, can we go to that position? And I think we had it in there. We say, look, it's redundant with is supported, but not all the way, needs serious house cleaning. Maybe it's time to do that house cleaning, right? Maybe we don't want to keep maintaining this complexity. And so I think we're just going to do this and take the hit of it breaking more things. Okay, so maybe kill things in target square. Who defines that? God, this program is so slow. I could have compiled the entire game 5 times. Okay, if it's a rock or a guy, this is not really, this is old. I think we want, we have this thing called type fills ocean squares, which means it's like a big heavy thing. That's not really, it's not necessarily the right name for it, but it's fine for now. So really, if you, I think this will be the right thing to do. Now, it's a little bit weird because you can definitely push stuff onto guys. But I think that happens and is supported. I don't know. Again, we, you know, we're just willing to break things, and we'll just see what the problems are and clean them up as they happen. Okay, so we say, here's the new position. We say, well, what did we just call it? Maybe physically move. We'll say, we're just going to go ahead and move it. Hopefully nothing catastrophic happens here. So again, we have this discrepancy between visual position and position. Hopefully, eventually we will get rid of that, but until we do, we need to maintain this. So maybe we kill things. Well, okay, so if needs physical move, this is a little bit redundant because maybe kill things in target square also does that. But you know, let's even. Okay. Why was I checking? I had a reason why I wanted to check needs physical move outside of this. I think we just want to handle teleport up here. This thing is just a HUD information thing that came from. It's not important for what we're doing, but I'm maintaining it. Okay, so till I remember why I wanted to do that, I'm not going to do it. Oh, because. So the thing is, this maybe physically move is being called by other stuff. Like, I don't necessarily want particle sources to kill things. Let's just see. Like, what we're trying to do, you know, in order to build this game and even figure out what game we were making, sort of a lot of if statements have accreted over time. And what we're trying to do is pack them together and make things more systemic. But you don't want to do that really. You want to understand what you're doing. And so, yeah. Okay. I think we want to get rid of this is falling variable. Oh, the reason why we wanted to do this is so that we know to fire off the other code. Which I guess this is, right? We've deleted so much of it that it's really not very much. Okay. So it's not a teleport because we returned if it was a teleport. Let's say old position. All right. So if we were above water and see, we really Let's actually use the proximity grid thing. We have cache proximity grid Z index. Okay, so let's do old Z. And water is at -1. Okay. I just had a really good idea for a level that I wrote down. Okay. So it's not physical end anymore. We don't want the visual interpolation. We're saying old Z is greater than or equal to 0. New Z is less than 0. Let's just say this. Now, we're not actually calling the frickin' this thing. Let's just say colon falling. I'm going to put on my list that I need to search for everything that says colon falling and fix it, because this probably won't work right. Okay. So we do this. Now this delta is wrong. This is like a 1 square long delta. And what we really want is yeah. So we want to get the gameplay DT of the energy of the entity manager. And we're going to say dx is v300 minus 1 times manager.gameplay dt times falling rate, where we're going to say falling rate is 1.0 if time per falling rate equals 1 over time per fall. This seems stupid because look, why are you checking this? Just don't ever define this to be 0, right? We're protecting against divide by 0 here. But we're about to make this data driven, and so somebody might type 0 into the slot, right? So, okay, we passed the wrong parameter there. Falling rate. Let's declare that. We're also, so there's all sorts of weird stuff going on. Like if we're supported, we don't just want to stop falling, but we're going to want to clamp our Z position so that we rest on the thing, because we're probably going to move our Z too far down so that we interpenetrate. So we're going to deal with that stuff. Let me write that down. I'm not answering off-topic questions right now. Don't ask. We're working on a problem. We are working on a specific problem. Don't ask me about vector clock-like events for distributed systems. I don't know why you think that's a programming language feature, but I also don't want to get into the discussion right now because we're working on other things. So we have an undeclared identifier. That should be easy. Easy peasy. Didn't I? Oh, we did that elsewhere. Okay. Let's dt. We called it dt, so we might as well use dt. Did it again. Okay, well, I think things might actually move downward now, but they may not behave well in other ways. Let's see. Boop. Hey, I can move. This guy can move. Wow. All right. Well, if I slow down time, it won't be pausing anymore. Right? Well, let's go to 3, 4. It's falling smoothly. So let's go to a level. This is a simple level with falling, and my guess is that the test will not play back correctly. It might actually play back correctly because the new falling may be slightly faster than the old falling because we don't take like a frame lag to set up a new interpolation or something, in which case the event just happens later. So we might luck out. Let's see. Okay, he didn't kill the guy. And for some reason, okay. He's like not in the right place in the proximity grid, so he's not lighting up, or she actually, it's a her. She's not lighting up the exit, which seems bad. Also, like, why is she like... Oh, she's 0.4 squares up. Right. So is it true? Let's see. It's possible that things are stopping falling. Our check for support is, whoops, is stopping things falling early. Yeah. So that's levitating. Okay. So that's like if I load this into the gameplay manager, yeah. So she's not triggering a proximity thing for that exit because she's not close enough because she is hovering. Hovering. Na 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 na, hovering. Okay. So we need to change is supported. We're checking is supported every frame. This is a thing where we need a relatively significant change. I think we just changed is supported itself to say that if your z coordinate is greater than 1 higher than the other thing, then no, you're not supported, right? I think that's a little bit scary, but because is supported affects so many things. But you know what? It's just where we're at. Okay. It's expecting a quantized position, right, is the thing as well. But we might want to do crazy levels where you want to walk across a bunch of falling things, in which case you're going to want to check for support for non-quantized positions. So we're going to say this now. We don't expect positions to be quantized. And again, this routine is complicated, but maybe it can be simplified. Oh yeah, this is a thing that determines if somebody can hold something up. This incomplete is no longer incomplete, so we can delete that. Okay. So we're doing a query, and we're just going to say if it's flat, then if e.position.z is less than, we're going to say epsilon, I don't even know, but yeah, is less than, what is our position.z minus 1. Actually, this is for things below, so we don't even need this. This is for things below us. We're searching at like z minus 1, so we're looking for the top of the entity below us. So we just say if e position.z is less than position.z minus 1 minus epsilon, continue. All right? So but then find mobile supporter is like a whole different deal that's also going to have to get this change. That's what is checking for lily pads. It's kind of redundant with what's here, and so I'm going to put that on the list. Find mobile supporter is supported. We want to combine these two things eventually. Okay, so find mobile supporter. We look for lily pads right now. Okay, it's only lily pads. So if lily.z support, we'll call this support epsilon. Right? If lily.z is less than pos.z minus support epsilon continue. Okay. Lily.position.z. All right. So now this might get us into trouble in other ways because, like I said, we're not like clamping things, but it should be closer. Let's see. Boop. Well. Nope, 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 nope. It is still there. Let's... Yeah, that's still floating as well. So first of all, let's start up on that level. Right? And then we want to figure out why this is happening. Because I would have thought that it wouldn't. Oh, you know what? Hold on. Remember when I said there's this like ocean grid thing? Oh, okay, we removed all these so on this level. So it's really stopping because it sees this. So I'm not sure why. So here's what we're going to do. When we go here and we say, if we're supported, stop falling, we're just going to put this back. Here we're just calling the same routine again. And what that'll just do is it'll let us put a breakpoint here, and then we can see what happened, because in principle, this doesn't change anything, right? As opposed to putting a breakpoint here, and this runs all the time, and then we would have to try to filter out the right time. We'd rather just do it here. So let's make a debug build, and oh, we're not even running Visual Studio today yet. We want to open it to falling. Okay, we're going to do that. So we push it, boom. Okay, why is it supported? So we find everything at the target position. That's one thing, all right? It's that wall cube that we're standing on. All right, so, duh, okay. This isn't about being embedded in a wall. I put this check in the wrong place. This is supposed to be a different thing. I'm just going to take this out, and we'll put it back in later when we know what we're doing. Oh, but also, we need to do this support epsilon check actually here. So, yeah, for some reason I skipped this in my brain. So it's like this loop does things at our z, and then this loop does things one below. Okay. Smooth support epsilon. And if e dot that's a little bit weird. This is redundant with the mobile support case. And we're going to want to clean that up. All right, what happens now? Maybe it's a disaster. Same thing. You are freaking me. Maybe the position is quantized. Whoops. I'm comparing it both to E, right? Oh no. No, I didn't. This position might be quantized for all I know. Because we're in this weird state. Hold on. What am I editing right now? Okay. E.position entity to visual position dot z. Okay. Let's try this. Let's try this. Let's try this. All right. Still same thing. But I want to do this as well. Well, we're back to the thing that we just did. Figure out why. Okay. Let's make sure, because we just recompiled, let's make sure it actually doesn't hit the floor. It doesn't. So now we'll do our breakpoint. Boop. Okay. Okay, interesting. I don't believe this is a wall, because that wall should be at z equals 0. I think this is the guy himself or something. It's the boulder. E is this entity. It's the same thing. The boulder is... Well, okay, we don't actually return there, first of all. But second of all, we shouldn't bother checking an entity against itself. That's goofy. Okay, so let's look here. Okay, okay. Okay. It's that check. It's that ocean-filled check that's going off. All right, so let's do that, and we'll do this here just for safekeeping. So this thing... Let's collapse these two things together. Okay, so we're just going to do this. Wait. What were we trying to say? We want to say just if we're here, then we're in the water. I'm going to make a new thing rather than trying to adapt the old thing. Underwater Visual Z -1. So if you've sunk into the water by 1 square, you just don't go any deeper. Okay, actually, I see what I was doing. So we want this, else. Okay, we want that, else. This is just to give us a floor of if we don't have an ocean entity on a level or whatever, or there's no water, things will stop at z equals 0. It helps you draft levels quickly, right? Or ship levels, right? So that still looks like it's is it floating by less? That would be weird. It looks like it's floating by less. What position is it at now? Okay. It used to be 0.4. Now it's 0.2321. We're making progress. It's like Zeno's paradox. Well, I'm glad you're getting stuff out of the stream. Bad habit 08. What does it mean for a position to be quantized? Well, okay. So because it's a grid-based game, for example, the canonical places for things to be, if you're thinking about the puzzle, are all at integer coordinates. So I have this block selected. If you look here, I mean, these are stored as floating point numbers, so they say 0.0, but they're all like integers, right? And so when I say before that there's a difference between the visual position and the physical position for things was always these integer numbers. It turns out that's not going to scale into a fully robust game. So we're relaxing that constraint. And because that constraint is not totally relaxed yet, I don't know if somebody is clamping the z value. Apparently it's not, okay, because this is not quantized to either 0 or 1, right? It's just an intermediate value. So that's okay. But there's a certain level of unsureness about what's going on because we're transitioning the system from one thing to another, which would be very bad if we were shipping the game right now. You don't want to be that unsure about what's going on, but we're not shipping the game right now. Okay, so I'm going to do the breakpoint again. We're going to see why it's, whoops, I skipped too far. Let's do it again. It's probably the same thing, honestly. we check if it's a wall before we check the position, right? Dum diddy dum. It's easy to miss that, okay, because this is supposed to be like an early out, but it's positioned in the middle of all these things that are about rejecting the possibility of the entity. So in my brain, I was like, oh, these are just like rejections, and then we start doing the real work. But this is like real work. So, well, I hope you never flag a wall as dead. That's all I'm saying. That's all I'm saying there. Hey, it went down to the ground. Now its Z is probably not completely 0. Yeah, it's a little bit under. That may cause us some problems. In fact, it may mean that thief level still doesn't work right, depending on what we do with this. But we'll take a look. Let me see if I can drop down there and push it. I can. And it can interact with things, so that's good. So let's try this one. Okay. We don't kill the guy, and that's going to make the level unsolvable. But let's drop down and see if we can go to the exit anyway. We can. I mean, I a little bit cheated by walking into the water. Let's temporarily just make ourselves a little bridge. It sort of ruins the point of the level, but we're falling and we're going, and okay. So that's good. So now, remember when I said, you know, maybe kill things in target square probably doesn't work? It doesn't work. So we're just going to look at that and see why the assumptions are now wrong and change. All right. Your position needs to really be 0 when you land. Well, it should be if the thing under you is exactly 1 unit high, which probably most walkable surfaces are going to be, although we might play with that. Because again, we have this thing in this game where, you know, like that skipping stone that we were standing on is like not that high. So we might want to like fudge your standing height by a little bit, but I don't think we want to do that too much. Otherwise we introduce ambiguity in puzzle solving and so forth. So, you know, okay. Maybe kill. Actually, let's see if it's universally broken for everything. And the way I will test that is by having a poor little monster down there. He's not bothering anybody. Yeah, he's fine. He's fine. No monsters were harmed in the making of this game. No problem. What is the reason I was relaxing constraint to have things at exact integer locations? Because if you can walk around on things that are falling, right? Or if something can be falling and then somebody starts pushing it while it's falling, then you just need to have physics interacting at non-integer locations or it's going to suck. What's a proximity grid? It's just our way that we search for entities in the world. Doesn't matter. It's going to change a lot. Doesn't matter. Okay. It's called maybe kill things in target square. Where is that? Oh, we searched for it. It's in simulate. Maybe kill things in target square. let's make it be in... This is the only time that this is ever called. So since we have moved, we're going to call it maybe kill things in current square. And we're going to know if the current square is the same or not. Does anyone else call check for kill? No, that's a private to us as well. Okay, so maybe kill things in current square. Okay. So if it's the same, if it.cached proximity grid index is not equal to e.cached. So we're going to make sure they're really stored in the same grid square, which will show us bugs if let's just do this. That'll show us bugs if the proximity grid is not right, but that would be inevitable. Okay. Yeah. Yeah. New position. Nah. All right. Didn't work. Okay. Oh, we can't view the proximity grid indices here. But we know it's in the right Z. We forgot to check the Z index here. Okay. What is going on? Let's make a simpler situation for the purposes of what we're doing. We only fall one square for now, and that will mean that we don't have to... It'll mean that we won't have breakpoint frustration problems. Like, we won't have to check the breakpoint for 8 squares as we fall. So let's debug build and maybe kill... Come on, bro. The text was not found. That's in falling. Maybe kill things in current square. Oh, we're in the wrong file. Dude, what is with this? Like, I'm... So it might be that this is not even what's physically moving us for whatever reason, and it's happening a different time. Let's just leave this as well, just for educational purposes. Okay. We have moved. Do kill is true. Boom. Found has one thing that bothers me. It's going to be that guy. Okay. So what's probably happening is this has to turn this position. That should still give the square. Let's do this. See what the hell is happening there. Okay, z coordinates match is killing us here, probably. Right? Yeah, okay. We're saying if the z coordinates are very different. And the reason that we don't want that is because, well, this used to make sense when everything was when everything was quantized, because 0.25 was just like an arbitrary boundary that was greater than 0 and less than 1, right? But now this is going to matter. This might screw up other things for all I know. Let's find out. Now we might have all sorts of problems with people thinking that other things are in there. All right, that was good. Yeah, now I can't move anywhere because z coordinates match. Because my z is a little bit into the ground, this z coordinates match thing is messing with us. So instead of doing that as a floating point test, now that we have this z index on the proximity grid, we're going to use that. Right, so instead of this, we're going to have if okay. So we want index and z index. All right, so if it.cached proximity grid z index is not equal to z index, continue. Hopefully we aren't getting a weird z index here, but we might be. We might be. All right. That also means we don't need to check the z index. All right, I can walk, I can push. Okay. should be able to jump on this guy. Nope. All right. So that's a different issue. Okay, different issue. Or similar. Similar but different. Oh. We're wrapping this with type fills ocean squares, which excludes characters like the thief. That's not what we want to do. So I think we now see, this checks whether we should kill things anyway. I didn't realize that when I did this. So I think we just do this. Boom! Boom! You know what that means? Test of this level will work. Let's test this level. Let's test this level. This involves falling. We're gonna have to do something about these sound effects. Okay, that didn't work. That didn't work. Okay, well, let's, this is Cowabunga. We're going to edit this level to set up a situation so that we don't have to Did I fall a square? I fell a square and I'm standing on the dragon. That is not what is supposed to happen there. So it's probably that our support check is not aware of the fact that we're going to kill this thing, but then why didn't that engage on the other monster situation? You know what I'm saying? Okay. Can I just go there? Okay, I fall all the way to the ground here. Maybe we're checking to kill that thing and it's returning false. Do I recommend learning C++? So this language has very little to do with C++ syntactically and not a lot semantically. And C++ is a giant morass. So I would not recommend learning C++ if you have a choice. I would recommend learning something that lets you do low-level programming. So like not Python, right? You know, maybe just C. Like maybe just C. It's fine. Okay. Did Casey's stream end? Why do we have 300 viewers now? Okay, so we're going to set a breakpoint there. And so I think we're going to go through this twice, and the first time we actually just ignore that, and then the second time we don't. But let's make sure we call it twice, because if we don't, that might actually be the problem. So I'm here, I step off, we call it once. Well, that's check for kill. And then we're supported. We are supported. So that's really the problem. We fall one square, and then this support check happens. So we need an exception in there, which I'm pretty sure we had before, and either we deleted it or it's not currently working. Okay. Well, let's look. So this would be in the below check, right? It wouldn't be in this one. It'll be here. So we're going below.z is minus one lower. We find things. It's not dead. It's not falling. It's not our own entity. Well, it's obviously not going to be too low. It's probably a little bit less than 1 below, right? So yeah, we're at like 0.95 and this is at 0. So we're just less than 1 square above it, and that's going to be the dragon. So we don't do this weight check. Okay. So it's doing DFA here that probably fails. Doing DFA is supposed to say, hey, we're not supported because we're trying to kill this monster. Whoa. Oh, it's the floor below the monster? No, it can't be. What? Okay, wait, hold on. E. What the hell is E? I don't have an easy way to tell. I have to dive way into here. Mesh. I just look at the mesh name. Soko 1 tiles plane. Oh, dude. Okay. This is a floor tile, and we took out a thing that thinks about floors. We should just say if it's flat. That probably takes care of that. If it's flat, it just can't reach up to the next square, so it shouldn't be considered in the below check. Didn't matter. So these little floor tile things only exist in a handful of levels because I decided a long time ago to get rid of them because they're an unnecessary complication. One thing I could do is like delete this one and replace it with this and see if the behavior changes. No, it doesn't. So that really wasn't the problem. Well, I mean, we've just simplified the problem again, so let's look at it again. I mean, let's just set a breakpoint. Well, I bet it's going to be that wall or the cube tile now. Okay, so let's enable that breakpoint that we just disabled and jump to there. So E, undoable data, mesh, resource. Oh, it's the dragon. So this if statement should go. I thought we skipped over that. Now it's doing DFA that failed. Okay, so it might have been that both things were problems. Sometimes that happens, right? You have two things breaking something and you fix one and you're like, oh, it's not fixed. It's because both factors were active, right? So if he's the thief, can pull means he's the thief or she's the thief. So, oh, this one, yeah. Okay. This is going to be on entity. Is it on undoable data? So we don't have all the same aliasing in the debugger that we do in the language. So sometimes I have to we're using all sorts of stuff in the struct, so I have to remember what the actual data structures are. We don't have to type any of this. In the actual language, we just say guy.z when falling started and it works. Okay, so targets undoable data position z 0. Okay. 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 So okay, here's what's going on. Because falling is now orthogonal to the other visual interpolations, we're starting falling before our sideways walk is complete. And so we have all these old checks that are checking whether how do you say it? We are checking whether we're in the same square, and because things used to be quantized that we used to pass here, then any old reasonable number would serve that purpose, right? So if things are going to be either 7 or 8, and you check if the distance is less than 0.1, then if they're 7, that's true, and they're 8, it's false. And this is just a way of having a very thick epsilon for this test, right? Well, now we're doing this transition test when he hasn't finished moving because we changed the movement system. So this is saying like, well, no, he's not close enough to nail the dude. Now, what we can use in the short term is the proximity grid square test, maybe even in the long term. So we can check to see if their cached proximity grid index is the same. And that'll be better than this. Let's see. If okay. So we just change that check. There we go. Okay, now we would like to test the level, but we have to revert our changes because the automated test won't play unless we're we also changed DFA tutorial, so let's revert that. Revert DFA tutorial. Oh, we also have to delete unversioned entities because of frickin', I don't like that part of the way Subversion works. Okay. And then Cowabunga, revert. Well, got to do it twice. Dude, there's too many menu options. All right. All right. So it's clean. We should be able to run it now and do the test. Succeed. Let's go to DFA tutorial and do the test. Succeed. Okay, so now we don't know of any levels that fail. There probably are, or there may well be. So we're going to make a release build and run the full test to see how we do. Remember, we still have this issue where the timing is probably different. And so maybe a lot of tests might fail because of that. But we're not sure. Any questions about what we've been doing? Any questions? Did I hear about Tree Sitter from GitHub? No, I have no idea what that is. Is there a timeline? No. No, no, no. I should put that in a 3,000 point font at the bottom of the Twitch page. Can I explain visual extrapolation? I already did sort of at the start of the stream. So if you missed that, it'll be on YouTube later, and maybe one of the previous streams that's on YouTube. There were a couple streams where we went really deep into that system and modified some things. All right, let's see what happens. Whoa, okay. Dramatic failure in the very first level. Question is, what is the very first level called again? Let's slow down time and test it. Air skating. Okay, so remember when I did all that stuff here's what's going on. We're trying to re-teleport every frame because we took out all the frame-based stuff, and that's not good, right? So we need to check that. So what's supposed to go on in here is my guy can step into one of these beams and it'll hold him up, right? So I go here, I should fall. But it's like teleporting me because I'm in the beam, and it's teleporting me every frame, and it's just going to do this until the end of time. And then the test gives up eventually because it says, like, dude, this isn't working. That looks pretty cool, though. It's just what happens when you have a lot of particles. Okay, well, that was a successful test in some sense. We need to make this work. Okay. Now, multiple weird things are happening. So one problem is support is okay. Like he's trying to teleport once. This is not obvious how to fix in a straightforward way. Because he's trying to teleport downward by, 2 squares because it's a double beam. And the reason is because he just barely crossed over the line into the beam. But really, in this case, we don't want that to kick off until you're fully in the beam. And so what's happening is the support check is probably returning false. I think we need a special case. That if we are falling, so the way that we decide that this guy should teleport is, beam effects get placed on him. There's a time during the frame when we trace out these beams through the level and we see who they hit. So at that time, I think we want to say, somebody needs to be really in the beam in Z before we hit him. Dude, I'm getting hungry. I'm getting hungry. Get some snacks. Now, I'm worried that this will start to get analog and mushy, which we don't really want it to. So we can just, for now, say this check only happens if he's falling. And then we have to make sure he can't, tunnel through the beam and all this weird stuff. Or no, maybe we just do it in falling itself. We're just going to need to record some additional information. I don't know, man. These are all the sound effects we are playing. Okay. What happens if there are two teleporter beams at the same tile? It depends on what type they are. Oh, you definitely cross the streams in this game. This ain't the Ghostbusters game. I'm not sure. I really legit don't know exactly what to do here. I need to think about it. This might be a good place to take a pause and we start a new stream later on when I've thought about it. Because there's different things. So you can have a beam going up, down, right? If that beam is going up, down, then you really don't want any non-discretization to sneak in. So I guess when you teleport, you snap the destination. Okay, we can solve... Well, we could definitely solve one problem at a time. So we could look at the visual interpolation and see if you're teleporting and say, well, you're already teleporting, let's not flail. That would fix part of what's going on here. It might fix enough, honestly. Let's try it. Let's try it. So that plus quantizing to the target position might fix enough for now. I feel like by the time we're done, we need to be more sophisticated than that. Okay. So if it's a teleport, if it's already teleporting, we just return. I think it's called teleport and disappear. Nope. Okay. Well, let's see what happens here. All right, well, we kind of fell into the thing. Because we're not checking the can go anymore. For some reason. So we need to check that. Okay, every move used to be discrete by a large distance, so we used to have this can go check in here that you may remember me deleting. We need that for teleports. We just don't want it for continuous fall. Let's find that by doing a diff falling diff. So we're going to look for can go. Oh, well. We have that check here. So I think we can just move this. I'm not completely sure, but I think we can just move this to there. We had 2 can go checks before. Whoops. Redeclaration of target. Okay. Because these teleport beams, if they would teleport you into an object, then you're supposed to be supported. Now, okay. This guy's visual position is a little bit goofy. And we need to fix that. Let's test the level. See if it works for gameplay. Nope. So our support test for when you're inside a beam and we're checking a long distance is not good yet, so we're going to kind of work around that for now. We're just going to say we quantize this position. Okay. Don't I already... feel like I might have this somewhere. Close this. Close. Close. Just close. Quit. I hate programs that do that. No, not quantize. Okay, mounts. Quantize. Yes. And then Okay. Those are no longer locally scoped to there. Okay. Okay. So we're just going to like snap it to the nearest square when it starts the teleport. So there's going to be a bit of a discontinuity right now. We'll fix it later. There we go. Okay, can we test this? This might be broken due to timing for all I know too. Like it certainly looks like this guy's trying to, well, okay, that guy ended up in a wall, which is not great. How did that happen? Wait, what? Wait, where did that wall come from? Did the wall fall? The wall fell down. The wall fell down. Yeah, well, it wasn't mounted, but yes, it had a problem. We're returning this in find supported entities for some reason. This happens sometimes when you simplify code. You like open up possibilities that were restricted before in ways that were not clear, but that were necessary. Let's try this. Okay, the wall didn't fall. Okay, so now I don't actually know if this level is broken due to physics or broken due to timing. So we're gonna do a record. Bop. It's probably due to timing because that teleport that teleport is going to change the timing or the quantization of the position. Okay, what do I do here? I think I go there and then there and then nope. This needs to go first, and then that, and then that. So it's playable. It's just the timing is messed up. Let's test it. Yeah, so this we expect, and we're just going to have to re-record timings sometimes. So we'll probably fail a number of levels. And hopefully they are all about being supported by beams. We'll see. Questions about what's happening? Do I also record undos and tests? Yes. That just seems like an important part of testing the whole system. And you would go crazy if you weren't allowed to make a mistake. A couple fails we expect. That one we didn't, so we're going to have to look into it. That one we did. That one, okay, we've got more fails than we wanted, but we'll look into it. Oh! The guy just undid himself right off the frickin' cliff. Alright, we're gonna get a big old list of fails when this is done. You could collapse undos after the recording happened, but you want to test undoing and redoing because that's part of the game that you're shipping, right? The goal is to test the game that you're shipping. So you don't want to get rid of things that people are going to do. It's going to take a few minutes for this to complete. What else is going on, people? To use something like the command pattern. What is this pattern stuff? Like, what is a command pattern? What does that even mean? You have to tell me what that means, because I don't know. What is a command pattern? Is that a telescope? No, it's a lamp. What else is going on? You're still wondering why you're using Ultra Search? Because every time I try a different search program, it's bad also. Dude, we're going to have so many fail baggers. So many fail baggers. Are we going to add something like IK for the characters? We will likely do that a little bit later once we've solved a lot of our big problems. Are we doing shadows in a similar way in Sokoban as in The Witness? Yeah, but it's just an easier problem. Because in The Witness, you have a long view distance, and so you need to do like these independent shadow cascades, whereas for a game like this, you just drop one shadow map on the scene and it's fine. No, I don't want a terminal-based search program. No. No terminal-based search programs. Is this game turning out bigger than expected? Yes, but that seems to be always how games go for me. You know? So we're going to have to go through all these fails and check to see if they're timing fails or legit fails. If they all seem like timing fails, I may check this in despite that, because we're going to have to change the timing again anyway later when we fix this more robustly, in which case we would have to re-record them all again, and that's just busy work, so we'll see what it seems like. What features does a search program need? I just want to see the list of files quickly that contain a string and possibly useful information about those files. Like, you know, if I can just click across the files and like just see the appropriate text in the file, that would be great. Nobody seems capable of shipping a search program that does that. Except frickin' Visual Studio. But then that's not really built to search random file trees. It's like really not very sophisticated what I'm looking for. And you know, you just want basic stuff like checkbox for case sensitive versus not case sensitive search, right? Checkbox for match white space exactly or don't. Couple of very basic options. You assume a game is never perfect. How do you decide when it's good enough to ship? You decide when it's good enough to ship. What I call Miyagakure a Sokoban game? A little bit, but not totally. I wouldn't totally. I would say it's a puzzle game. Should the replay test be timing independent? No! There are a bunch of streams where I explain why we needed time tests. You can watch them on YouTube. A lot of the tests are timing independent, but some of them are not and cannot be. What algorithm are you using for ray triangle intersection? We are testing the triangle against the ray. It's not an algorithm. Ray triangle intersection is just a geometric primitive. It's not an algorithm, really. I mean, you can do it different ways, like by barycentric coordinates or whatever, but who cares? Uh-oh, mirror teleports kind of failed. We can't step on stuff that falls into water. Why do enemies lag the game so much? Because I haven't optimized that code, and who cares? Because it's not important right now. Have I tried grepwin? Anything with the word grep gives me hives, so maybe not. How did both of these guys fall down? I don't want a grep program. I want to search for simple strings in files. Well, that's messed up. I mean, if it manages to do regular expressions and all that, I'm fine with that. But since nobody seems to be able to make an acceptable program that doesn't even do regular expressions, then don't even bother telling me about regular expressions, because I'm not interested. Like, if I want to do something painful that has to do with regular expressions, I already have Emacs for that, right? So, all right. So we're going to have a boatload of fails, and it seems like there's no point in looking for timing fails yet, because we have this basic problem that rocks that fall into water are not in the right, they're not supporting correctly in some way. They're probably not being registered in the right place in the proximity grid. And that may be because they don't go through the regular falling routine for various reasons. Let's see. So this probably works. This probably, oh, this works. This probably doesn't work. Mirror 3, right? So we push that. Oh no, that one works. Bro, I don't... We were definitely seeing some of these levels fail. Maybe they only fail when playing back test for some reason. Like, he couldn't go there. Oops. Why couldn't he go there? I can go there. So there's some difference between test playback and regular playback that I don't understand. Oh. It's probably because the test system is waiting for a falling transaction to complete. And we don't do that anymore. Right, the recording has transactions in it. So if I re-record this, I don't know if I need to make it a timed recording. If I need to make it a timed recording, we may take a stream break and deal with this later. So how do I solve this from here? Oh, I put this here. Timed. Whoops. Okay. It seems like we need to record timed tests for all falling right now. That is not desirable because a lot of levels have things where you push stuff into the water by one square. And so we had a special case for that. And that special case, I guess, is not really working right now. Let's... Well, it looks like it is, though. Like, it's going down. And the linear move is still on it once it goes down. So the coordinates are going to change if you look behind. See that? The coordinates change. And it goes... Oh! It's doing that thing where it snaps to the bottom again. We're going to want to fix that. Okay, yeah, this is what's happening is this has nothing to do with the falling code. It's deciding that it is supported and then killing the visual interpolation and because it's killing the visual interpolation, the gameplay testing is not really completing or something. Might be a separate issue, but we at least want to fix this snapping problem. Recently started in AAA game dev. While you're excited, kind of afraid of getting into the habits of ridiculous C++. Do you have any recommendations on what you should do to not get into the mindset where you start to accept these things as normal? Well, just be exposed to alternative opinions, and it sounds like you are already. So I think you're probably okay. Yeah, so when I push a block into the water like this, it doesn't use the regular falling system, and you might be like, why? And the answer is really because you don't, like, you want a simple drop like this to be part of the player transaction system so that the buffered move system knows, like, oh, I pushed something into the water, and then I pushed forward again. We're going to not try to go forward until that's done falling into the water, because obviously, right? We're not going to try to move into it and then bump there. So it's sort of just like a heuristic about deciding it's an ergonomic modification, right? Okay. The thing is, I feel like I kind of want to break because we've been streaming for a couple hours and it's a chill weekend. So I'm going to write on the list, the next thing to do is fix snap in falling blocks. And then we need this level to test correctly. Mirror 7. And once that tests correctly, then we can rerun the global test again. We're not going to check this in because we don't want to break the whole game test-wise. Even though it seems like you can play things, it's like, we should at least fix this. So I'm certain this is not going to be the only issue that we introduced, but it is one that we should fix. So I'm going to take a break. We'll probably do some more programming tonight. Yeah, thanks everybody for coming by. And we'll see you later on sometime. Let's see if there's someone to raid or something. Let's see. Because that's fun sometimes. We don't need to raid Grimm's. He killed us a couple of times, so we shall not do that. Science and technology. Programming. There's a lot of bugs crawling around the screen. I don't see anything happening.
Here we go.
Oh.
This is what's going to happen. It's going to get big. It's going to get boof.
Buff dad lore. All right. Let's raid this. We're going to raid some buff dad lore. Thanks everybody for coming by. And we'll see you later.
Oh man, what is this ridiculous raid? Guys, worm defense. Worm defense.